In this video, we are going to learn symmetric matrix, skew-symmetric matrix, and orthogonal matrix. Let's start with symmetric matrix. A matrix A is said to be symmetric matrix if A is equal to A transpose. Take an example. Let A is equal to 1, 2, 2, 3. Then A transpose having columns which are rows in A, which is 1, 2 is a first row in A, then 1, 2 as a column in A transpose, then 2, 3 is a row in A matrix, then 2, 3 is a column in A transpose. Now A and A transpose both are 2 by 2 and having corresponding element are equal. Now A is equal to A transpose, that is A is symmetric matrix. B is equal to n matrix having element 1, 2, 3, 2, 3, 4, 3, 4, 5. Now B transpose, first row in B is 1, 2, 3. Therefore first column in B transpose is 1, 2, 3. Second row is 2, 3, 4. Therefore second column is 2, 3. Third row is 3, 4, 5. Therefore third column is 3, 4, 5. Now order of the both matrix is 3 by 3 and corresponding element in both matrix are equal. Therefore B is equal to P transpose, that is B matrix is a symmetric matrix. Now skew symmetric matrix. A matrix A is said to be skew symmetric matrix if A is equal to minus A transpose. Let A is equal to n matrix 0, 1, minus 2, minus 1, 0, 3, 2, minus 3, 0. Now A transpose is 0, 1, minus 2, minus 1, 0, 3, 2, minus 3, 0. Now minus A transpose is equal to n matrix 0, 1, minus 2, minus 1, 0, 3, 2, minus 3, 0. Both the matrix are 3 by 3 and both the matrix having corresponding element are same. Therefore A is equal to minus A transpose, that is A is a skew symmetric matrix. B is equal to n matrix 0, minus 1, 1, 0. Then B transpose is n matrix 0, minus 1, 1, 0. Then minus B transpose is n matrix 0, minus 1, 1, 0. That is B is equal to minus B transpose. Therefore B is also a skew symmetric matrix. Now orthogonal matrix. An n cross n matrix A is an orthogonal if A into A transpose is equal to I, where I is an identity matrix, or A transpose is equal to A inverse. Now let's take an example. Let A is equal to n matrix 1, 0, 0, minus 1. Let's check it is orthogonal or not. Let's find A transpose which have columns which are rows in a matrix, which is 1, 0, 0, minus 1. Now let's multiply A into A transpose, which is equal to 1, 0, 0, minus 1 into 1, 0, 0, minus 1. Now number of rows in A is equal to number of columns in A transpose. Therefore the multiplication is exist. Now multiply first row in A to first column in A transpose, which is 1 into 1 plus 0 into 0. Now first row of A to second column of A transpose, which is 1 into 0 plus 0 into minus 1. Now multiply second row to first column, which is 0 into 1 plus minus 1 into 0. Now second row to second column, which is 0 into 0 plus minus 1 into minus 1. Now which is equal to 1 plus 0 0 plus 0, 0 plus 0, 0 plus minus 1 into minus 1 is 1. Now which is equal to 1 0 0 1 and identity. Now we get A into A transpose is equal to an identity matrix. That is A is orthogonal matrix. Here are some examples of orthogonal matrices. In the next video, we are going to learn determinants of order 2 and 3 and the determinant of the matrices.